Okay, guys, welcome to the trig identity lesson number 2. So for this lesson, what I want to do is I'm just going to do more questions and to show you different skills when you prove trig identity questions. All right, so let's start with the first one. Again, it's a proof question. Let's start with the first question here. Okay, all right. So you've got an an identity right now. So obviously you're going to start from the left-hand side. By using the trig identity formula, you're going to prove the left-hand side. Everything you can simplify to cotangent theta. All right, so let's have a look at the question here. There's a power of 3 for both cosine and sine, a denominator and a numerator. And you also can see some cosine and sine. So maybe the idea behind is to factorize. All right, so I'd like to factorize cosine theta out. So cos theta is equal, all right, bracket, 2 cos square theta minus 1 over. And for the denominator, you've got sine theta here, you've got sine cube theta there. You can take the sine theta out. So that gives you cos square theta minus sine square theta. All right, now I hope you can realize that. Okay, that's cosine theta, that's sine theta. Cosine divided by sine is cotangent. So hopefully you realize, I need to, cancel these two out. These two should be the same terms. All right, so let's continue. Cos theta, 2 cosine square theta minus 1 over sine theta, cos square theta minus. All right, how do we change the sine square theta to cos square theta? Well, there is a formula. I remember from the last lesson, we did sine square plus cos square is equal to 1. So therefore, sine square theta is equal to 1 minus cos square theta. So 1 minus cos square theta. But remember, you also need to put another bracket. So after we remove the brackets, this sign is going to change to positive. And there will be a bracket here. All right, so you get cos theta, bracket 2 cos square theta minus 1 over sine theta, bracket, this 2 is 2 cos square theta minus 1. So finally, you can cross out these two expressions, and then you have cos over sine, and that is equal to cotangent theta, which is equal to the right-hand side. So that's how you prove this trig identity question. Okay, so the things you need to think about when you solve a question like this one is you have to carefully observe the left-hand side and see what's in common and try to do some factorization if you can't. And then try to observe what's happening here. There's only a sine on the top, there's sine and cos. So you might be thinking about using a formula to change sine to everything to cos. And that way you can actually remove the term. All right, so these two terms cross out. All right, so this is question A. All right, let's move on to another question. All right, let's try question another one here. Let's call this question B. So sec theta plus tangent theta plus cotangent theta is equal to 1 plus sine theta over sine theta and cos theta here. All right. How do we do this question here? Like, where should I start? Should I start from the left-hand side or should I start from the right-hand side? I still believe that it's better to start from the left-hand side, because for the right-hand side, it's not going to be that easy to do it. So let's just start from the left-hand side. All right, but what do we do with the left-hand side? Now, you need to observe. That's sec, tangent, cotangent. None of these three trig ratios are in the answers here. In the answer, you have sine and cos. So this is something that you need to think about, all right? If on the left-hand side, nothing in terms of sine and cos, however, on the right-hand side, we've got sine and cos, then what's the relationship between them? All right, so obviously what we need to do is to change every single term here to something in terms of sine or cosine or maybe both. I'll start with the first one. Using the reciprocal identity, sec is 1 over cosine. Tangent, using the ratio identity, is sine over cos. And cotangent is cos over sine. Alright, that's pretty easy. Once we finish that, what we can do now is to, I guess, make the same denominator for every single term. And then the common denominator will be sine theta, cos theta. Which now you can see it's on the right hand side. You've got sine theta, cos theta. So we're sort of quite close to the answers now. Alright, so 1 times by sine theta plus, we need sine theta again, so sine squared theta plus, we need to times this term by cos theta, so that becomes cos squared theta. And then I hope you realize that sine squared plus cos squared is equal to 1, so therefore that gives us 1 plus sine theta over sine theta cos theta, which is equal to the right hand side. Alright, so another question where you require you to observe the questions very carefully and see what is the the tricky part of the question and where we can how do we work out the questions here. Alright, that's a good one. Another good question here. Alright, shall we do another one? Alright, let's do another one. Let's do question C. Alright, so let's try this one here. It looks pretty hard. Alright, let's see if if we can do it. So question C. Cos A minus tangent A sine A over cos A plus tangent A sine A is equal to 1 minus 2 sine square A. Alright, it looks pretty hard. Okay, see, let's see how do we do this question here. As usual, I'm going to start from the left hand side. You've got fractions, you've got more stuff you can do. Alright, now if you look at the right hand side, you've got sine only. There is no cosine, there is no tangent. What do we do with that? So it looks like what we need to do is we need to try our best to remove the cosine and remove the sine, and remove the cosine, remove the tangent, so hopefully we have the sine left. Maybe you've got another way to do it, but at this stage, I believe what I would do is try to change the tangent into sine over cos and see what happens. Maybe it will help us to do the question, maybe not, but let's start with that. Because it looks like that's the only things we can do. Alright, sine A over cos A. Sine A. Alright, now once you get to this point, now I'm the person that I don't like fractions inside another fractions. So what I would do is I would multiply both the top and the numerator and denominator by a common term, which is cosine A. The reason for that is because I want to remove the cos A and cos A here. Alright, so let's start with this. Cos A times by cos A is cos square A. Minus cos A and cos A, these two cancels out. So you've got sine times by sine, that becomes sine square A. Now if we do the same thing for the denominator, we are going to get cos square A plus sine square A. And by now, I hope you realize this denominator is just equals to 1. So we've got a numerator which is cos square A minus sine square A. Alright, now let's compare. We've got cos square A minus sine square A. That's 1 minus 2 sine square A. Oh, cosine disappeared. How do we change cosine? Well, the way we can do it is we can change cosine using Pythagorean identity. That is equal to 1 minus sine square A minus sine square A. And that obviously gives you 2 sine square A. And then the final answer is the correct answer from the right hand side. Alright, so the thinking behind with this question here is that's tangent, cos, sine. The tangent has a common term in terms of sine and cos. So this is the idea. Try to change tangent in terms of sine and cos, so everything's in terms of sine and cos, and you might be able to simplify it by do some algebra calculation, for example, by removing the denominator here, times both the numerator and denominator by cosine theta, A, and then you get to a point where you can simply use another Pythagorean identity to remove the denominator because that's equal to 1, and then you can follow that process to prove to the right hand side. All right, let's do another one. We're probably going to try maybe 5 questions. That should give you enough idea about how to do the trig identity questions today. All right, let's try question D. Let's see if that question, all right, that looks pretty good. 1 over 1 plus tangent square x minus 1 over 1 plus sec square x is equal to cosine to the power 4x over 1 plus cosine square x. All right. That's pretty crazy. What do we do? Always a question like this. And how do we do it? What should I do with this? Obviously, we'll start from the left-hand side. Okay, we're going to start from the left-hand side. I'm thinking about so many things here right now, all right? Because we know what's 1 plus tangent square. 1 plus tangent square is sec square, all right? So that's sec square. And 1 plus sec square, well, we can change that in terms of tangent. There's a lot of things to do. You can also try to do this question by changing the tangent into sine over cos, because that's all in terms of a cos, and change that into 1 over cos. Again, because that's in terms of cos. So you've got a few options you can use. But what I think the easy way for this question here, all right, we're going to try, okay? Let's see if that works. Maybe it's not going to work, all right? Maybe it works. Let's see. Let's use the Pythagorean identity. 1 plus tangent square x is sec square x. Let's at least do this one. All right. Now for the other term, how about we just change that sec square into 1 over cosine square x? So at least like everything's in terms of cosine. Well, this one is actually in terms of cosine because 1 over sec square is cosine x. Cosine square x. That looks pretty good. Everything is in terms of cosine right now. All right, for the right hand side, this term here, what we need to do is to combine the denominator. So that becomes cosine square x plus 1 over cos square x. All right, keep going. It looks like we are going to get the final answer. We're going to do the reciprocal of the denominator here because that's 1 over the entire term. So that gives us cos square x over cos square x plus 1. Now, looks like we've got the right denominator now. Okay, so the final step is just going to make the same denominator. So you are going to get cosine to the power 4x plus cosine square x. Remember, you're going to times this term by the denominator here, and that's how you get the answer. Minus cos square x. Wow, and that's how you cancel these two terms out. So now you have everything ready, and that is equal to the right-hand side. So not many steps, right? But the problem here is you've got too many options you can use. You can change tangent into sine over cos. You can change sec into 1 over cos. You can even do the 1 plus tangent equal to sec. You probably, if you don't have an experience, that you don't know what to do, you probably, when you first start to do the trig identities, you will struggle a bit. You're going to try one method, it's not working, and you're going to, probably waste like 30 minutes and then move on to another method. But that's okay. Everything right now you're doing is to improve your knowledge and try to expand that knowledge. So next time when you see a similar question like this, you know what to do. All right, so we're going to do one last one. And I really think that's enough. Okay, all right. Question E. Okay, how about we do this one here? That looks pretty easy. Cos theta over 1 minus tangent theta plus sine theta over 1 minus cos theta is equal to sine theta plus cosine theta. All right, here's the question. Now, I hope after we try so many examples, you've realized, we're going to start from the left-hand side and we probably need to change that tangent and cotangent, or in terms of sine and cos, because that's what you have on the right hand side. So let's start to do that. All right, to do that. So that's 1 minus sine over cos, and then that's 1 minus cosine over sine. Okay, all right. What do we do now? Get rid of the denominator. Yep. So how about we times this fraction, top and bottom, by cosine theta. So you get cosine square theta over cosine theta minus sine theta. And do the same thing for that one, but this time we're going to multiply this fraction by both top and bottom by sine theta. So we've got sine square theta over sine theta minus cos theta. Okay. All right, now let's have a look at the denominator. They looks very, very similar to each other. One is just a minus b, the other one is just b minus a. So all we need to do is really simple. I'm just going to change that, because changing from sine theta minus cos theta to cos theta minus sine theta, you just need to put a negative in the front, and that gives you cos theta minus sine theta. All right, looks pretty good. So now we just combine the two fractions. We're going to get cos square theta minus sine square theta over cos theta minus sine theta. Well, still not the answer yet. And then if you look at the numerator here, it's not cos square theta plus sine square theta. It's cos square theta minus sine square theta. All right, so how do we do that? Well, look at the denominator. They're very similar. So this is what you do. All right, you're going to use something like you have learned in year 9. It's called difference of two squares. So your numerator is going to get, become cos theta plus sine theta cos theta minus sine theta over, and then denominator is still equals to cos theta minus sine theta. And then I hope by this time you realize that you can cancel these two terms out, and then the answer is just cos theta plus sine theta, and that's the right hand side. So it's pretty tricky, yes. So common mistake is students realize this, believe that the numerator is equal to 1, which is not. It's only 1 if this is a plus, then it's equal to 1. And now, however, you realize this one, you can use the difference of two squares to factorize, and you can cancel one of the factor on the denominator to get to the final answer there. And that becomes the final answer. And another tricky part is like, how do I change this one? Change the plus to minus, and then change the order, switch the order around if you look at it. All right, this is one of the tricky parts. So the way I remember is if you want to change a minus b to b minus a, all you need to do is to put a negative in front of b minus a, and then you can change that into a minus b. That way, all right, you can quickly turn these two terms around, and that's one of the little tricks I use in algebra. Okay, all right, so that's it. So I think 5 questions. They're enough for you to start with your trig identity questions. They are going to be hard when you first study it. That's my experience when I was a student. I struggled a lot because there are so many different options you can do this question here. But obviously, do the question, spend the time, eventually you'll get better. Okay, I will see you guys next lesson. Thank you.